Welcome to the lesson. This is for Wednesday, 9/16, and we're looking at the notes for multiplying binomials and factoring binomials. One quick definition here. Standard form ax plus bx plus c equals 0. We've been graphing these so far this week, but we just want to define this as standard form where it's set equal to 0. A is the first number in front of x squared, b is the number in front of x, and c is the constant by itself. We'll be using that actually through the next several weeks. Distributive property, quick review of distributive property. When I'm dealing with binomials, x minus 3 times x plus 5 means you take this first x and you distribute it into x plus 5, and you take the minus 3 and you distribute that in as well, giving me x squared, x times x, 5x, negative 3x, and negative 15 when you distribute. Now you may have also learned this, that first outer inner last, where you multiply the first terms and then the outside terms. But look at what we just did. When I did those two letters, F and O, is I distributed the x. And then I do the inside and then the last. And again, look at what we just did. We distributed the negative 3. So it's really distributive property that you're doing when you do that first outer inner last from Algebra 1. So once I've distributed, I do see some like terms here in the middle. 5x minus 3x is 2x. And I get this as a final answer. That should be something we've seen before, something you're pretty used to. Another example here, I'm taking the 4x and distributing it in. 4x times 3x is 12x squared. 4x times negative 5, negative 20. Distribute the 7 in as well. 7 times 3 is 21x. 7 times negative 5, negative 35. And note, these two middle terms, again, are like terms. Negative 20 plus 21. Oh, I just saw an error there. It should be a plus there. Would be plus 12x squared plus x minus 35. Okay, so that's just a quick review of multiplying. What we want to focus on today is factoring these, working backwards. And you did a little bit of this in Algebra 1 as well, but I find students aren't great at it, so we're going to spend a little bit of time on it here. So factoring binomials means dividing polynomials up into their parts. This one, 8x, can be broken up into 6x and 2x. And then broken up further into x plus 6 and x plus 2. But the way you've probably learned it is what factors of 12 give me 8. They have to multiply to make this and add up or subtract to make that middle term. And if you look at the factors I have, 6 times 2, that makes 12 at the end. And think about it, we're working backwards from the distributive property. So if I distribute this, x times x makes x squared. Outer is 2x. The inner, or the inside numbers, make 6x. 2x plus 6x equals that 8x in the middle. 6 times 2 gives me 12. So it's just the reverse of that distributive property we looked at in the first example. So let's try a few. And everybody has a slightly different approach. I'm going to kind of lay it out in fine detail. If you don't need all these details and you can just look at it, factor it out, and you've got it, then you can skip some of these details that I'm about to try and lay out for others. So when I'm looking at this equation, I'm trying to find the factors of 36, that last number c, factors of c, negative 36, that will add or subtract to make 9. So the factors of 36, that could be 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Which one of those sets of factors would also give me 9, whether it adds to it or subtracts to it? Well, none of them add up to 9. But I see this set of factors here, 3 and 12. That would subtract to make 9. So we're going to use two binomials and break it up using 3 and 12. So now the first part should be easy. X squared is x times x. So that's always the same for these. And so what factors of 36? Well, we said 3 and 12. But remember, I need a positive 9. So if I did this, look at the outside. Negative 12, and the inside gives me 3. Negative 12 plus 3 is negative 9. So that doesn't work for us. So I need x minus 3 and x plus 12. I needed a positive 9, so the bigger of the two factors got the plus sign. So that makes positive 9. And then we can check our answer. And you don't have to show any work for this. You can just check it mentally even. X times x is x squared, 12x minus 3x, and negative 3 times 12. So if you just distribute that out, you should get the same answer we had at the beginning, that equation at the beginning there. Okay, and we do. So we know that this is, in fact, the answer. Okay, now I'm on to number 3. Let me get rid of some of those. On to number 3. I'm going to try to do the same thing, same exact type of example, only with 70. So again, this x squared is easy. I know that it's going to be x times x in the first parts, at least for these easier ones. I'm looking at 70. How do I break up 70? Well, there's only a few options. 1 and 70, but 1 and 70 don't make 17. 2 and 35, but those don't add or subtract to make 17. But if I did 10 and 7, I could get 17 out of that. So I need to use 10 and 7, but notice I need a negative 17 in the middle. So I can't make either of those plus. A negative 10 and a negative 7 will add up to negative 17. Plus, we also know when multiplying a negative times a negative, that would make positive 70, which is what I have in my problem. So as we check this out, we know that this will also work. X squared outside would give me 7x, the inside would give me minus 10x, and then the last terms would give me plus 70, and there's your negative 17 in the middle. So we know that this is, in fact, the answer. All right, let's go a little bit harder, talking about finding a combination of factors using the number in front and the number. So if there's a number in front of x squared, we have to do a little bit more work. And I do give you a hint here. The hint is if the number in the middle, b, is relatively small, use factors that are close together. If it's relatively large, use factors further apart. This is pretty small compared to the other two. So we're going to use factors close together. So let's start. Factors of 5. 1 and 5. Well, that's it. It's prime. Factors of 14. 1 and 14, but those aren't close together. And we just said that this is relatively small, so we want ones that are close together. So I'm going to use 2 and 7. So here's the combination that I want to use. So let's put this into parentheses. Now it's no longer just x and x, because look at the first term. The first term has to be 5x squared. So 5x times x makes 5x squared. There's my 5 and 1. 5 and an unseen 1 right here. And then, deleted the wrong number. And then I need to place 2 and 7. Well, I need to find the right combination to make that work. So if I put 7 here and 2 here, the outside would give me 35. And again, we're mainly concerned with the outside and the inside combos to get 3x. So the outside, it's getting rid of the wrong stuff here. The outside is going to give me 35 if I have 7 here and 2 here. I don't want 35. That's nowhere near 3. That's not going to work. So we're going to put the 2 here. And we're going to put the 7 here. So now I get 10 on the outside, 10x, 7x on the inside, but I need to get a plus 3 out of that. Okay, so let's make the 10 positive and the 7 minus. So 10 minus 7 gives me the right combination to make 3x. And you can check that. You can distribute this out. And we've kind of already checked it here by doing this outside and inside stuff. And you'll see that it gives you back this original equation. All right, let's do one more. And honestly, at this point, if you think you understand it, you're welcome to jump out. You don't have to stay for this last example. But let's give this one a try. We're looking for combinations of 6. Well, that's 1 and 6 and 2 and 3. But again, look at this middle number. That's not that big, especially considering the numbers that are around it, the 6 and the 36. It's not really small, but it's not really large either. So I'm probably not going to use 1 and 6. So I'm going to stick with the factors 2 and 3 to make 6. Then I look at 36. Oh boy, there's 36 again. It has a bunch of different factors. 1 and 36, but I don't want factors far apart because 35 isn't that big. 2 and 18, that's also kind of big. Maybe 3 and 12. So maybe I'll use 3 and 12. Maybe you use 4 and 9. I think 6 and 6 are too close because the number's not that small. So one of these combinations is going to work. So let's make our parentheses and let's just see if we can figure it out. I'm pretty confident I'm sticking with 2 and 3. Now if that doesn't work, I will switch to 1 and 6. But let's try 2x here and 3x here. And I'm just throwing them in just to see what works and doesn't work. Now if I try 3 and 12, I don't know if I can get the right combination. Like if I put 3 here and 12 here, look at the outside. 12 times 2 is 24. Inside, 9. I mean, we're getting pretty close, but that's going to give me 33, and I want 35. So I don't think we're quite there with the 3 and the 12. Even if I switch those around, I think that would just make it even worse. So we're going to try the 4 and 9. So I could put 4 here, but if you remember stuff about GCFs, you're never going to have a GCF inside of the same parentheses. So the fact that this is a factor of 2 means the 9's probably going to go here. Let me get my pen back. The 9's going to go here and the 4 is going to go here. So you don't have two numbers in the same parentheses that have the same common factor. Now let's check it. Outside gives me 8x. Inside gives me 27x. 8 and 27 do in fact add up to 35. Both can be plus because that works for all the signs. So I have the right combination here. So it's kind of a matter of elimination. Just trying to see which factors work, which factors do not. At this point you can pause the video, you can start working on the homework. I am going to show an alternative approach. Most people don't like this approach that I'm about to show, but for some people it really works. So if it works for you, that's fine. So if you're looking for maybe a different way of looking at these, I'm going to explain that now. This is totally optional though. Okay, so we're looking at an equation like this. It's the one that we did just a little bit ago. Factors of 5 and factors of 14. Another approach that you can take, as it zooms out on me, another approach that you can take is to multiply the first and last numbers together, what we called A and C. And so if I multiply those together, I end up with negative 70. So let's just find factors of that combined number, negative 70, that give me 3. And I think pretty clearly you can recognize 10 and 7. 10 minus 7 would give me positive 3x. So I'm going to break up this middle term, this 3x up here, right here, and I'm going to break it up into two terms. So I'm going to break it up into 10x and minus 7x, the two numbers that I came up with over here, and you can see it right here in the middle. So 5x squared plus 10x minus 7x minus 14. So I took the 3x and broke it up into two terms. And if you remember GCFs from Algebra 1, we're going to take a GCF out of the first two terms. They both share a 5, and they both share an x. Oh, that squared's not supposed to be there. They both share a 5, and they both share an x. And then I'm left with x plus 2. In the second two terms, they both share a minus, and they both share a 7. So when you take negative 7 out, I get x plus 2. Now notice both parts have an x plus 2. So if I take x plus 2 out, I'd be left with the 5x minus 7. Now these marks are jumping everywhere, but ignore that x squared there. So again, just to quickly repeat, that squared is not supposed to be in there. But I have x plus 2, that's one factor, and the GCFs that I took out, 5x minus 7, make up the other factor. So it's kind of a more methodical approach instead of guessing and checking. Some people with this clicks for. If you want to use it, you're welcome to. All right. If you watch this segment of it, you can jump out now and start your homework.